Hi. In this video, I'm going to show you how to solve and give you some tips on how to solve a word problem involving a quadratic equation. So first of all, remember what a quadratic equation is. A quadratic equation is an equation that involves a polynomial that has one variable and the highest degree is 2. And so you've been learning all kinds of methods for solving quadratic equations, but they basically all boil down to two methods: factoring or the quadratic formula. Now, factoring, in both cases actually, you have to always get everything over on one side and make sure you have a 0 on the other side before you can start doing anything. So if you're going to factor, you have to make sure you have a 0 on one side and the polynomial on the other side, and then you try to factor it. And you have a product of two things equaling 0, which means that one of the two factors, at least one of them, had to be 0 to begin with, and that's the zero product property. And if you use the quadratic formula, you also have to have a 0 on one side, have your entire polynomial, all like terms combined over on one side, have a 0 on the other side. Okay? The other two methods were the square root property and completing the square. You can use those, they'll work, but they're basically just the same as the quadratic formula. So use those only if you've forgotten the quadratic formula, if you couldn't memorize it. Okay, so let's look at our first problem. So in this problem, it says a ball is thrown from a height of 79 meters with an initial downward velocity of 6 meters per second. The ball's height, h in meters, after t seconds is given by the following. And they give the equation h equals 79 minus 6t minus 5t squared. And then the question is, how long after the ball is thrown does it hit the ground? And it says to round your answers to the nearest hundredth. So this has a lot of information in it, but most of it you don't need. All you really need is the equation. And also the picture is helpful. So here's the picture. So let's first try to understand what this equation means, so we understand what we're doing. So it says that a ball is thrown from a height of 79 meters. And if we look at the picture, we can see the ball is coming down from the top of a building. So that must mean the ball is being thrown from the top of that building, and that building is 79 meters tall. And then in the drawing, we can see the h represents the height of the ball at time t. And from the picture, we can see that the height means the distance from the ground. That's what the height of the ball means. Not the distance from the top of the building, but the distance from the ground. And as the ball is going down, that distance is shrinking, right? It's decreasing. All right. So let's think about a situation. Well, first of all, what are they asking us for? They're asking us for how long, and that means time. How long usually means how much time. So let's think about a particular time. What is going on when t equals 0? So t equals 0 means 0 seconds after the ball has been thrown. And that just means that the ball hasn't been thrown. Hasn't been thrown at all, right? So where is it when it hasn't been thrown? It should be at the top of that building. It should be 79 meters high, 79 meters from the ground. Well, let's see if that's true. Let's put t equals 0 into that equation. So h will be 79 minus 5 times 0, minus 6 times 0 minus 5 times 0 squared. So 6 times 0 is 0. 5 times 0 squared is 0. So we do get positive 79. So it is 79 meters from the ground when t is equal to 0. So that makes sense. Okay, so now what are we asked to find in this problem? It says how long after the ball is thrown does it hit the ground? Well, hitting the ground means what? It means the ball is exactly 0 meters high, right? When it hits the ground, the distance from the ground is 0. So that means that we can plug in 0 for h. So let's do that. 0 is equal to 79 minus 6t minus 5t squared. So this is a quadratic equation. It's a polynomial. The highest degree is 2, and there's only one variable. Okay, great. It's not in standard form. We do have everything over on one side and a 0 on the other side, which is good. But now we have to put it in standard form. And standard form means that as you go from left to right, the degrees of the terms are going down. We have to put them in descending order. So let's just rearrange it. So it's negative 5t squared minus 6t plus 79 equals 0. So now it's in standard form, and we can either factor if it's factorable, or we can use the quadratic formula. So my recommendation is when you're not told which method to use, and you're thinking of factoring, just look at it. Don't spend more than 2 seconds on it. If it doesn't look like you can factor it right away, just do the quadratic formula, which means you do have to memorize it. And also remember, some polynomials won't be factorable at all, and you'll have to use the quadratic formula. Okay, so the quadratic formula says once you have it in standard form, then your variable t will be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what are a, b, and c? Putting it in standard form is really important for finding a, b, and c. A, b, and c are the 3 coefficients in your polynomial going from left to right. So negative 5 is a, negative 6 is b, and positive 79 is c in this particular equation. So now I'm going to put those numbers in. So my variable t is equal to negative 6, that's negative b, plus or minus the square root of negative 6 squared minus 4 times negative 5 times positive 79. All of that over 2 times negative 5. Okay, so now I'm going to simplify a little bit. So negative 6 is really positive 6. And then I have plus or minus the square root of negative 6 squared is negative 6 times negative 6, which is positive 36. And then negative 4 times negative 5 is positive 20 times positive 79 is positive 1,580. And then the denominator, I have negative 10. Okay, it's not simplified all the way yet, but as I simplify, I also have to split it apart. Remember what that plus or minus means. It means that we actually have 2 answers. 6 plus that radical over negative 10, and 6 minus that radical over negative 10. So I'm going to split it into 2 solutions and simplify at the same time. So the first one is t equals 6 plus the square root of 1,616 over negative 10. And then we have t equals 6 minus the square root of 1,616 all over negative 10. Okay, and so we're going to want to start putting these into our calculator. But before we do that, I want to deal with the minus sign because I don't want to lose it or make a mistake. In the second solution, I have 2 minus signs I need to worry about. So let's simplify a little more before we use the calculator. So let's look at the first one first. T equals 6 plus that radical over negative 10. When we have a minus sign in the denominator, we can bring that out front or put it upstairs in front of the numerator, in front of the whole fraction or just in front of the numerator. So I'm going to put it in front of the whole fraction, which means I have to use parentheses. So t is equal to negative and then parentheses and then 6 plus radical 1,616 over positive 10. Okay, and I'm going to do that in the second one too. The other solution, if I bring that minus sign out in front, the minus sign that's in the denominator, bring it out in front, I get t is equal to minus, and then parentheses, 6 minus the square root of 1,616 all over positive 10. Okay. So now let's go back and look at the first one again. Now, when we look at that, we've got 6 inside the parentheses. So we've got 6 plus that radical over positive 10 inside the parentheses. And then there's a minus sign in front of all of that. So inside the parentheses, we clearly have a positive number. And then we have a minus sign in front of that positive number. That means that t is negative. And what does that mean? Well, we saw that when t was 0, the ball hadn't been thrown yet. And we're looking for the time after the ball has been thrown when it hits the ground. So we're looking for a positive number, a positive answer. And this answer is negative. What does negative t mean? Since when t is 0, that's just before the ball is thrown. When t is negative, that's way before the ball was thrown. So we're going to throw out a negative answer. It's just not going to make sense for us. So we're going to cross that out. So now let's look at the second one. The second one has a minus sign in front too, but the thing inside may not be positive. In fact, I can tell it's going to be negative. The stuff inside that, the parentheses, that's got to be negative. Because that square root of 1,616 is a lot bigger than 6. And so it's going to be 6 minus some number bigger than 6. Well, that's got to be negative. So that's something negative over positive 10. So that's negative. We put a minus sign in front of that. That makes it positive. So we know the second answer is going to be a positive number. But let's simplify it a little bit so that putting it into the calculator is not messy. So since there's a minus sign out in front of the parentheses, I can just distribute that minus sign in the numerator. I can just leave the denominator positive. And so I really get in the numerator a negative 6 plus the square root of 1,616 over positive 10. Okay? And so this is easier to put into a calculator. And so now I'm going to show you the steps for putting this into a TI-30XA calculator so that you don't mess up. And also, because I don't want you rounding anything until the very, very end of the problem. So if you put that 1,616, take the square root, and then write down some number, and then later subtract 6 from it and divide by 10, you're rounding too soon. You're rounding before you're subtracting 6 and dividing by 10. I want you to leave the rounding till the very, very, very last step. So you're going to leave everything in your calculator. And so this one's not very complicated, but just to be clear what I'm doing. So first I put in the number in my calculator, 1,616. And then I hit the square root button, and my calculator shows me a number. And it shows me about 6 or 7 digits, but I know it goes on a lot longer than that. And actually the calculator remembers a few more digits, which is good. But it's showing me just the first few. And then I'm going to hit the minus subtraction key 6. And now it doesn't show me a number, so I have to hit the equal button. And now it shows me a number. And then I do divide and then 10. And if it doesn't show me a number, I have to hit equals again. And then it shows me a really long number, and it remembers a lot more digits than it shows. And now I have to do my rounding. So I'm just rounding at the very end of the problem. So it said to round it to the nearest hundredth. The hundredth is that second decimal place. So right now it's a 1. So I'm either going to round up to make it a 2, or I'm going to round down, which means I'm going to leave it as a 1. And to decide which way we're going to go, we look at the number right next to it. It's a 9. So if the number right next to it is greater than or equal to 5, we're going to round up. If it's between 0 and if it's 1, 2, 3, or 4, we're going to round down. So in this case, it's 9, which is greater than or equal to 5. So that means I'm going to round up. And so my answer is approximately 3.42. So I rounded that 1 up. And don't forget the units. It's 3.42 seconds. So 3.42 seconds after that ball is thrown is when it hits the ground. All right. So remember in this problem, we were looking for the time that it took for the ball to hit the ground. And so we're solving for t, which means we have to plug something in for h. And the thing we plug in for h in this situation was 0, because hitting the ground means the height had to be 0. So it's slightly different from the next example. So the next one says a model rocket is launched with an initial upward velocity of 204 feet per second. The rocket's height h in feet after t seconds is given by the following, and the equation says h equals 204t minus 16t squared. And then it says find all values of t for which the rocket's height is 100 feet, and round your answers to the nearest hundredth. All right, so let's think about what's going on in this situation. We can see from the picture, this time the thing is going up. In the previous problem, the ball was coming down from the top of the building. Here, the rocket is being launched, and it looks like it's being launched from the ground level. It doesn't say that explicitly in the problem. It just says it's being launched. But if we look at the picture, it looks like it started out on the ground. So the initial height, even though it didn't tell us in the wording, we can tell from the picture, the initial height was 0, a distance of 0 from the ground. And let's see if that's actually true. Initial means t equals 0. So let's take that equation and let's plug in t equals 0 and see. The height has to be 204 times 0 minus 16 times 0 squared. So clearly 204 times 0 is 0 and 16 times 0 squared is 0. So we did get 0. So that makes sense. Our picture looks like the rocket starts out at ground level, and the equation tells us, in fact, that it does start out at ground level. Okay. So it's 0 feet high when t equals 0. Great. So now find all values of t. So we're looking for time again, for which the rocket's height is 100 feet. So what do they mean, all values of t? Well, let's look at the picture and see what that might mean. So the rocket's height is 100 feet. Well, let's draw a horizontal line for h equals 100. So if h equals 100, I drew a little line. So there's 100 feet. And if we look at the picture, it looks like the rocket has passed through 100 feet at some point. There's a point in time when the rocket was 100 feet high. And so we're looking for that time. But don't forget, this is a toy rocket. It's a model rocket. It's not a real rocket. It's not going to go to the moon. It's not going to go up forever. It's got to come down at some point. Whatever goes up must come down, right? So that rocket reaches some maximum at some point. It turns around and it comes back down. And if we look at that, what I've just drawn, you can see there's another time when it's 100 feet high. So it looks like there's going to be 2 times, not just 1 time, when that rocket is 100 feet high. So let's see if we can find both of those times. So we're going to plug in h equals 100. So 100 equals 204 times t minus 16 t squared. That's a quadratic equation. It's an equation, has 1 variable, is a polynomial, its degree is 2. So we want to get this in standard form before we do anything. So that means get everything over on one side, have a 0 on the other. So that means I'm going to subtract 100 from both sides. And that gives me 0 equals 204t minus 16t squared minus 100. Good. But now we need to put it in standard form. We need to make sure that it's in descending, the degrees are in descending order. So I'm going to rewrite it as negative 16t squared plus 204t minus 100 equals 0. And now I look at that. I can't factor it quickly, and it might not be factorable at all. So I'm just going to go straight for the quadratic formula. So A is negative 16, B is 204, and C is negative 100. So let's plug those into the quadratic formula. So T has to be negative 204 plus or minus the square root of 204 squared minus 4 times negative 16 times negative 100. All of that is over 2 times negative 16. All right, so let's simplify a little bit and break it up into 2 possible solutions. So T equals negative 204 plus the square root of, I got the 35,216 over negative 32. And the other one is T equals negative 204 minus the square root of 35,216 all over negative 32. So let's think about this. We do need 2 answers based on our picture and what we saw. If we're going to be 100 feet high, at some point we're going to have to do it again coming down. At some point going up and at some point going down. So we might want to look at these answers and make sure that they are both positive. Let's do that thing again where we take the minus sign. Notice in each one we have a minus sign in the denominator. Let's take that minus sign out in front and then distribute it into the numerator. So in the first one, I first get negative and then parentheses, negative 204 plus that radical all over positive 32. And now I'm going to distribute that minus sign in the numerator. So that means I have a positive 204 minus that radical. And that's all going to be over positive 32. And now that is going to turn out to be a positive number because the square root of 35,000 is smaller than 204. And if If you don't believe me, put it in your calculator. But I can tell that my number sense tells me that. Mainly because if I square the 204, I know I'm going to get 40,000, more than 40,000. And so that's bigger than 35,216. So I know that's going to be positive. So let's look at the other one. If we do the same thing with the other solution, we're going to get t is equal to positive 204 plus that square root all over positive 32. And that one is clearly positive. All right, so now I put these into my calculator. So again, the order that you would do it so that you don't round too soon is you put in that number 35,216, you take the square root of it, change it to a negative, then add 204, and then divide everything by 32. And so when I do that, I get t equals, and then I rounded, approximately 0.51 seconds. So about a half a second after the rocket is launched, it's 100 feet off the ground. That's a pretty fast model rocket. The second one gives me t is approximately 12.24 seconds. So it's 100 feet off the ground twice. Once on the way up, about a half a second after it's launched, and then it keeps going up, and then about 12 seconds later, it's coming down, and it's 100 feet off the ground about 12 seconds later. So it must have gotten pretty high, somewhere between a half a second and 12.24 seconds. It reached its maximum height, turned around, and started coming down. So after this next exam, we're going to learn how to find when it reaches its maximum height. But we don't have to learn that right now. So those are the two examples, the two basic types of problems. One is where you're looking for when something hits the ground, and the other one is looking for when something reaches a certain height. And so sometimes you have one answer, usually hitting the ground, you only have one answer, can only hit the ground once. Or sometimes you might have two answers. So if you're looking for when it passes through a certain height, it's usually once on the way up and once on the way down. So these are all quadratic equations, something being thrown off of a building or something being launched from the ground. They're all basically the same. And so in each one of these, you plug in a number for h and you solve it for t. Okay, so this will be on your test, so make sure you understand it. If you have any questions, let me know. Happy solving.